Hi, so in this video, we are going to take a look at the interview question where you'll be given a linked list and you have to determine whether a cycle exists in a linked list or not. So in the solve function, you will be given the head pointer itself, and with the help of it, you have to go about solving the problem. We're going to take a look at two approaches. The first one is using the set and the second one is using the slow and fast pointer approach. So let's get started in the video. So in this case, suppose I have to determine whether basically the linked list is cycle or not. So in this case, I can just use a set. Why? See, suppose I encounter one node, I'll put it in the set, and I encounter that same node at some point of a time again, then I know for a fact that okay, it's in the set, so I know for a fact cycle exists, right? So in this case, suppose the set is something like this. Also, I'm not going to store the number. I'm going to store the entire node itself. I hope you get my point. So what if I just store the number? Suppose 10 is here and then 10 is again here. So in this case, if I store 10 here and I encounter 10 again, I will say that cycle exists. But up till now, was there a cycle? No, right? So I'll store the node itself. Why? See, when I store the node, I have two different sort of like the values here. The first one is the data in the node and second one is the next pointer, right? Next pointer. So kind of like data and next pointer combined both kind of exhibits a uniqueness of that node itself. Okay, I hope you get my point. So in this case, suppose I'm just going to write here node 1, and right now I'm not going to write node 2, node 3. I'm just going to write suppose node 2, node 3. This is node 4 and this is node 5, and I can see that okay, this is a cycle here which is forming. So what I'll do is okay, I'll just go naively. What do I mean by naive approach? I mean the brute force approach. So from head, I'll go till node 1. Is node 1 in my set? No. So I'll just have node 1 here. Is node 2 in my set? No. I'll have node 2. Is node 3 in my set? Not at all. I'll have node 3. Is node 4 there? No. Is node 5 there? No. Now, when I go in this manner, right, I encounter node 3. So is node 3 in my set? Yes. So in this case, I can just simply return true. Return true, and this true is going to denote that okay, the cycle exists. Else at the end of the code I can just simply return false, which kind of denotes that okay, the cycle never existed in the linked list. Okay, so let's try to code it out. It won't take a lot of time. After this we are going to take a look at one of the best approach, which according to me is the slow and fast pointer approach, and I also talk about the drawback of this current approach using set. Let's see, this is the function define cycle check. Head is the something which is you will be given. Head is nothing but the start of the linked list. So let's see, I'm going to create a set like my set is going to be initialized as follows. So you can initialize set as follows in Python. Let's see what we can do now. So I'll have something like okay, my current pointer is nothing but at head. Also, why am I not going with the head pointer itself? Why am I not going along with the head pointer? Like head is equivalent to head dot next. See, because I kind of don't want to remove the reference to the beginning of the linked list. I'm just using a different pointer here, and that's not an issue at all. I hope it makes sense. So right now what I'll do is that okay, while current, so it means that okay, while current, while my current node exists, then I'll continue. So while current, my current value is nothing but current node itself. So what I'll do is that okay, if current in my set, okay, so if current not in my set, it means that okay, it's not there. So I'll just add it. So my set dot add my current value itself. Else if it's there, I know for a fact what I'll do is I can just simply return true, which means that okay, a cycle exists. Else if this never gets encountered, what I'll do is I'll return false. But is it really it for the while sort of like the loop here? No, I'll have to move my current pointer as well. So my current will be equivalent to current dot next. Okay, and why am I doing next? Because I know for a fact the node has these two things, data value and the dot next parameter, which kind of gives us the location or the reference to the next node. Okay, and at the end of the code I can just simply return my value false. That's it. Okay, let's talk about a more optimized approach. And why is this not an optimized approach? See, we are kind of looping in the linked list once only, so the time complexity here is big O of n, where n is the length of the linked list. I hope you get my point. But the thing is that okay, I'm also occupying big O of n space in the worst case. Why? See, the set here is going to occupy all the linked list nodes, right, at some point of a time. So it's a big O of n space complexity approach, which is kind of okay. But what if you want to optimize it? What if you want to optimize it? Let's see. So right now I'm just going to save it quickly and let's jump into the second approach. The second approach says that, okay, maintain 2 pointers slow and fast. And I'm going to increase slow pointer. I'm going to increase slow pointer by 1, increase by 1, and I'm going to increase fast pointer by 2. That's pretty much it. And at some point of a time, if my slow pointer equals or is equivalent to the fast pointer, in that case, I can simply return true, which means that, okay, the cycle exists in the linked list. Else at the end of the code, I can just simply return false. I can just simply return false. That's pretty much it. And let's see if this is working or not. So I have a slow pointer and a fast pointer. I'll just get rid of it. I'm going to denote slow and fast as follows. So let me just write it. I'm going to write, suppose slow is here as of now and fast is also here. Both of them are here at the beginning as of now. Okay, great. My fast is going to go 2 steps forward. My fast is as of now here. Slow moves 1 step forward. Okay. Now my fast goes 2 steps forward. So fast is here and slow is up here. My fast is going to go, maybe I can just increase slow first. So suppose slow goes 1 step forward, it is up here. Now my fast is going to go 2 steps forward. So 1, 2. So now my fast comes up here. And I can see here that, okay, slow and fast are kind of at the same position, right? So I can happily say that when they are equal, if slow is equivalent to fast, in that case, I can just simply return that, okay, cycle exists. What if there was no cycle? What if there was no cycle? What if there was no cycle? In that case, what will really happen? Let's see. I'll just get rid of all of those slow fast. My bad. So I'll just get rid of slow fast. And now see, slow and fast is here. Next step, slow is here, fast is here. Next step, slow is here, fast is here. And next step, basically slow will come up here. So slow will come up here and fast will be out of like bounds of the linked list, right? So it will be somewhere close to none. And I can see that, okay, they will never match. Slow and fast will never match. So I can in that case say that, okay, false, that, okay, there is no cycle in the linked list. I hope you get my point. So with respect to that, let's try to code it out. So my slow pointer is going to be nothing but initialize with head. And same as fast, it's the same thing goes for fast. So fast is also going to be initialized with head. So while fast and fast dot next, okay, while fast and fast dot next. So what this means is, okay, it will go till so what I can do is I can just simply write while fast as well. That's not an issue at all. Okay, while fast as well. Now why am I writing while fast and fast dot next? See, I'm going to write that only, but why am I writing fast and fast dot next? Suppose my fast is here. So what I can do is that, okay, I can go while fast, yes, fast exists, and fast dot next, yes, it is there. So I'll go. But what if my fast is here? What if my fast is here? While fast and fast dot next, but fast dot next is none. So I won't continue here. So this is the point where I'll break. So therefore I'll just write while fast and fast dot next. You have to understand why you are writing each and everything. You can't just go about writing on your own. Okay. Right now what I'll do is I'll increase my slow pointer by 1 step forward. So slow is equivalent to slow dot next. And my fast value will be nothing but fast dot next dot. Notice here that I can kind of pair up the dot next value twice and it won't be an issue at all. Okay. At this point of a time, what I can see is that, okay, if slow comes out to be equivalent to fast, I know for a fact I encountered a cycle here. So I can just return. That's pretty much it. And at the end of the code, what I'll do is that, okay, I'll just return false just to denote that, okay, the cycle is not there. The cycle is not there. Okay? If this is never getting encountered, then this will get encountered by default. Okay. What is the time complexity here? Again, the time will be nothing but big O of n, close to big O of n. Okay. And the space will be big O of 1 itself because I'm not occupying a lot of space here. You might be saying that, okay, slow and fast pointer is going to occupy space. So maybe like 4 bytes and 4 bytes, it's 8 bytes. So kind of like, what if the length of the linked list is 10 to the power 5 or 10 to the power 6? Then 8 bytes is nothing, right? In comparison to 10 to the power 5 length. So you get my point, right? So that's pretty much it for the code. And this is the basics of the linked list interview questions. We're going to cover most of the advanced ones as well in the coming videos. So if you find the video helpful, please do make sure to like and subscribe the channel, and we'll meet in the next video. Thank you.